Okay, so today we will discuss about digital image processing. So suppose you want to visit a place in Bangladesh like Kaptai or Chittagong or Dhaka or Rajshahi, then what you will do if you don't know the destination, proper destination, then what you will do? You will be using Google Map, right? So that is known as like you want to go to a tour, that is tourism. So you will visit the place like as I have given the example like Rajshahi or Sylhet, then you will be using Google Map application. By that application you can go anywhere you want to go or you want to visit easily if you do not know the exact location. So another system is known as interactive system. So what does interactive system that means? Interactive system uses neuroimage processing or neuroimaging. For example, neuronet, brain AI, then cortex AI. If we go to the next slide, that is what is it? It is written as MIT AI, right? MIT artificial intelligence. So it is used for neuroimaging, brain research, and healthcare. MIT researchers, in collaboration with recently in collaboration or some years back, they made some collaboration with Harvard, are exploring ML techniques, that is machine learning techniques for clinical neuroimaging. These tools are applied to large scale data sets to enable early detection, prediction, and treatment of brain related diseases. So what does that means? What they goal for or what they are aiming at? They are aiming at a bridge gap to between the research and clinical applications. So what does this means or what is the image of this is called? You can write in the uh, section where in the comment section like what does that means after pausing the video. So when I am showing you the image, it's we will discuss about fMRI. fMRI. So what does that means? That means that functional magnetic resonance imaging. So it is used for or it is a type of neuroimaging technique that measures brain activity by detecting changes in blood flow. So when a brain region is more active, like what does the if MRI means or how we can use it? We have already a traditional MRI. So why we will be using fMRI? So fMRI, that is we have already said that a functional magnetic resonance imaging. So when a brain region is more active, it consumes more amount of oxygen, and fMRI can capture this by highlighting areas with increased blood oxygen levels. Commonly used in this type of image is commonly used in research, medical diagnostics, and to understand brain functions and abnormalities. So we already know that fMRI, the advantage or how we can use it. So another question is rising, like how if MRI differs or distinguishes from traditional MRI. We already have a traditional MRI, so how we can distinguish from fMRI? So in traditional MRI used for anatomical imaging to visualize the structure of your brain and other tissues. It provides high resolution images of brain anatomy, helping to diagnose conditions like, for example, we can say that tumors, brain injuries, or structured abnormalities. Uses it is used or it is used in the fields or it uses some techniques which is known as magnetic fields and radio waves to generate images based on density of protons in tissues, and it does not follow or it does not provide functional information about brain activity which we are getting from functional MRI. And fMRI uses, and it is the image of that is traditional MRI. There we use radio waves, or we give radiotherapy while we using a traditional MRI. And fMRI we use bold, BOLD, bold contrast mechanism. So what does BOLD, bold, means, or what does it stands for? So bold means blood, B for blood, then O stands for oxygen, L stands for level, and D stands for dependent. That is, fMRI used bold contrast mechanism, and the bold section stands for blood oxygen level dependent, as it measures the activity or the rate of oxygen level. And it is used, fMRI is used in cognitive neuroscience, and in also psychology, that is study brain function, then neural basis of your behavior in the real time scenario. That's why we use fMRI, that is functional MRI, right? After that, we will say that in case of digital image processing, why does we use digital image processing in our research or in our studies? For monitoring, for detection, and for response of different types of activities or issues. After that, we are proceeding to another image or the picture or slide, that is we are visualizing it is a car, inside car scenario or indoor car scenario, and there is a monitor or screen. It's showing what? It's showing navigation, right? Navigation. So we are now using navigation system, right? Navigation system. So why does we use those type of navigation system? So we can say that for enhancing driver safety, utilizing various technologies and features to assist drivers or to help drivers and to improve road safety, we are using navigation systems. So if we give some components or some bullet points, what does we will be using after visualizing the image which is showing in your screen? That is GPS navigation. Okay, so GPS navigation, what does it do? It provides real-time location data and route information. And by using this, we are having the visualization of road conditions, if there is any traffic jam or not, how is the road, or if there is any occurrence of any accident or not, we can visualize by the help of GPS navigation. After that, another thing is coming, that is ADS, right? So ADS, what does it's written, the circle of safety. So what does ADS means? ADS stands for Advanced Driver Assistance Systems. Advanced Driver Assistance Systems. So how we will discuss about that? First of all, we need to know about the LDW. LDW, so what does it stands for? LDW stands for lane departure warning. So it will alert the driver if they drift out of their lane without signaling. Sometimes what does the driver does in if we are using local bus, without giving any signal, the driver just changes the lane, right? So for this we need ADS, and in ADS section we have lane departure warning. If any driver changes the drift of their lane without signaling, it will signal, or it will automatically give the signal or the sound. It will give a sound also. Okay, after that we are proceeding to and the type of image. What does that means? That means it is a picture of ACC. Okay, not Afghanistan Cricket Board. It is stands for adaptive cruise control. So automatically it will adjust the vehicle's speed to maintain a safe distance from the vehicle ahead, right? So what does it will do? it will just give the signal, or it will use the technique or the technologies to identify the speed of the next vehicle, if that another vehicle from my vehicle is safe, is meeting the safety distance or not. After that, we are having a blind spot detection. It will warn the driver of the vehicle in their blind spot or not. After that, we are having collision avoidance systems. So collision means what? Collision means there is some occurrence of some accidents if there is any collision. So it will be using some sensors and cameras to detect and potential collisions. So for using it, it will be using AEB. AEB, that is automatic emergency brakes. It will activate brakes if a collision is happening or a collision is imminent. FCW, forward collision warning, it will alert the driver of potential impacts it is occurring or not. So we have already said about the navigation system and some components of the navigation systems, what we will be using if we want to develop a system, or if you want to develop a project regarding navigation system. So there is a question arising, or the question may come like, does CNN play a role in case of navigation system? You can pause the video and answer in the comment section below. So yes, the answer is yes. Convolution CNN, what does it stands for? CNN stands for Convolutional Neural Networks, CNN. It will play a significant role in enhancing navigation and driver safety through various applications in digital image processing. So first of all, object detection will be done, or the component will be object detection. So what does it will do? It will detect, classify the object in vehicle's environment. It is crucial, or it is very much important for ADAS. What does ADS means? ADS stands for Advanced Driver Assistance Systems, ADS. Okay. And it will also collision avoidance systems. It will also be helping to avoid the collision. Then it is coming lane detection. CNNs, that is convolutional neural network, also can analyze video feeds from cameras mounted on vehicles to identify lane markings on road. If there is any marking or not, if there is any person sitting or not, everything will be done by using the monitoring of the cameras, which will be situated beside the roads. Okay, so by that we can detect the objects, and also by that we can detect the lanes also. After that, if you want to develop a system by using, like if you want to do the research by using for example, some people are sitting in the darkness and you took the image, or if you took the, if you capture the picture, and as they are sitting in the darkness, the image might not sound proper to you, or the image might not captured proper by you. There will be some visibility of some darkness. The dark intensity will be huge than the brighter section. So what you will need to do, you will need to increase the contrast of that image. Okay, so if you have lots of image, then you will be not you will prefer to not doing that by one to one. You will be using some model, or if you want to do the larger project, or if you want to do the impactful project for the society or the environment, then obviously you will be using larger data set. So you can name it it as image enhancement using CNNs. Image, that is picture enhancement, color contrast you will be increasing using convolutional neural networks. So what does you will need to do at first step or first phase? At first phase or first step, you need to choose the data. You need to prepare your data set. So we can name it as data set preparation. So you will be collecting a data set of low light images and their corresponding high quality images. This could be done by clicking pictures or capturing the same scene or the same portion or the same section or the same segment in different lighting conditions. It will be the first phase or the first step. Second step will be CNN architecture, that is convolutional neural network architecture. You will be designing a convolutional neural network architecture which will be tailored for image enhancement to use an encoder and decoder architecture or structure. So what does I have said that you will be using in the second phase decoder, encoder and decoder structure. So while using encoder structure, you will be reducing the image spatial, not spatial. I have the word is spatial, spatial dimensions while extracting features. And in the decoding section, you will be reconstructing the enhanced image from these features. After that, in the third phase or the third step, you will be training your CNN. The model learns to map low light images to their enhanced versions. For example, you can you will be using loss function, LOSS loss function, MAC, that is mean squared error. How well enhanced images matched with your target high quality image. For that you will be using loss function MEC. After that you will be applying your trained model for the enhancement of your particular image which already is in a dark phase, right? So this is the structured way or the procedure of proceeding a research work. If you are heading or if you are aiming to do the research in digital image processing, then you can follow the procedure what I have discussed or what I have uh, suggested you or advised you. So this is all for today. Thank you.